said, I'll use a different color here. We said X is equal to the number of grams of aluminum hydroxide. And that correlates to the number of moles of nitric acid. Decided to keep everything in that calculation as red. We'll use everything in this calculation as a slight blue. So what could I do then to find out the other part that I need? I would also need to know this part of the equation. So we're going to make an assumption. We're going to assume that the mass of the total tablet, we're going to ignore, and this is like an assumption. So this is like one of those things you have to assume that it throws problems off a little bit. The total tablet, whatever the mass of the tablet would be, we'll call this made of X grams of aluminum hydroxide. And we also want to know, like, the number of grams of magnesium hydroxide. Probably don't need those. All right. So the total tablet, well, that's up here. It's 0.4826 grams. That's like the total tablet combined. That's going to be equal to X plus the number of grams of magnesium hydroxide. Right? Well, this isn't like major algebra. If I wanted to find out an expression, or if I wanted to have an expression, so the number of grams of magnesium hydroxide, that would be the same as the, well, okay, so the total tablet is this. And we're going to call the portion that's due to the aluminum hydroxide to be X. So if we do this, the remainder, whatever X is, right? So whatever X turns out to be, it's going to be what's left over, the 0.4826, right? So here we have another expression. Whoops. We have an expression for the number of grams of magnesium hydroxide. So what we did up here to find out the number of moles, we'll just copy it over. What we did up there to find this, we can do the same thing to find out how many moles of nitric acid was used for the magnesium hydroxide. So we would just have to make some changes, right? Instead of having grams, X grams of this, we would put in the expression uh, 0.4826 minus X grams of magnesium hydroxide. And then from here, you could actually find out how many moles magnesium hydroxide would be. We'd have a different mathematical expression. Of course, we would have to change from grams of magnesium hydroxide to moles. We would use the magnesium hydroxide here. So we would use the molar mass here for magnesium hydroxide. We would use the molar ratio here for the second equation. Now we have a 2-to-1 ratio. And we could proceed the same way, and what we would end up with, see, we wouldn't be using this. We would find out how many, the number of moles of HNO3 used to neutralize the magnesium hydroxide. And we could put that number like right here. I'll just put that number. All right, so this got to be number of moles, right? Number of moles, because this is in moles. So this would be number of moles magnesium hydroxide. Now, if you think about it, we would actually have an expression here, right? So we would have an expression this is the total HNO3 moles used to neutralize both. This represents the portion we'll put our labels on the bottom. This represents the portion of this total amount that was used to neutralize the aluminum hydroxide. And then whatever this expression turned out to be, that would represent the moles of the HNO3, the portion of this total number of moles of HNO3 that was used to neutralize the magnesium hydroxide. Need more paper. Let me get some more paper. So, well, this would be X though, right? This would be X. Now I left that out. I'm not used to using that. So this is actually what we set up here. This is where this came from, right down here. So we would have an expression where we would have an algebraic expression which would solve for X. And once we did this, I'm leaving out the algebra steps, I'm leaving that for you to work on. We would have an expression where X, if you recall right from the beginning, X represents the number of grams of AlOH3. So if we took this expression and solved for X, we would know how many grams of aluminum hydroxide would be present in the tablet. And we could use that information, we'll represent a new phase here, to calculate what the actual bottom line question is. The bottom line question is, what's the mass percent of the aluminum hydroxide? So the percentage of aluminum hydroxide that was in the original tablet, right? Tablet, I get to draw here, so there's like a certain percentage, a certain portion of this. So what's the percent of the aluminum hydroxide in this tablet? So the percentages, of course, are part over whole. Times 100. The part of the tablet, which is aluminum hydroxide, is the number of grams of aluminum hydroxide. It would be this answer right here, whatever it turns out to be. The whole tablet was given up in the question stem. The mass of the whole tablet is right here, 0.4826 grams. We are actually home free because we can actually calculate. Once we know this number, we can calculate the percentage, because this is how many grams in the total tablet, and this will represent the grams of the aluminum hydroxide. Okay, so that's the strategy. This is the entire strategy laid out, exactly how to arrive at the answer. Now, when I worked this one out, and I rounded my answer to 2 significant figures. Well, let me give you a part of this, because if I give you the answer, you can work it backwards. But the answer that I came up with for this X, if you do everything correctly, should be 0.18 grams of aluminum hydroxide. How you get there is going to be whether you successfully navigate through the algebra that we have up here. So if we put in 0.18 here and divide this out, round to the 2 sig figs, that would be like 37% aluminum hydroxide. All right, so this is a frustrating problem. It's guaranteed to give you some issues. However, it is the type of problem that you would normally see on a part 2. It's one of those questions that would be like on a free response question, deep into it. It wouldn't be like question A where they ask you to do something like write the equilibrium expression or anything like that. The A part, the B part, the C part, as you go deeper down the free response question, the questions become progressively harder. So this would be a difficult question, and this would be like a lower part, a lower answer. This is the type of question that's going to separate the people who deserve to get a 5 from the people who deserve to get a 4, if that makes sense to you. So this is a challenge. I actually mapped out the strategy, so you can actually, if you go back through this and work your way through the algebra and do the calculations, see if you can arrive at this answer for the number of grams of aluminum hydroxide. And of course, if you get that answer, everybody can go from here to here, I would imagine, because that is just a pre-AP question that we would have. Well, good luck with this. Remember, the answer is going to be displayed for you tomorrow on 3/20, which is tomorrow, and you will have the answer for that and the other answers that are on this worksheet. Okay, so they'll be available to you tomorrow. For right now, see if you can work through this just one challenging problem. The other problems on here I thought were pretty straightforward, so you'll see the answers for those as well. But I would really like to see how you do on this question, because that's going to be the difference between somebody getting a 4 and somebody getting a 5, I would imagine. Okay, that's all I have for you for today. Tomorrow you will get your answer keys, and I'll have new assignments for you starting tomorrow. So good luck. Enjoy your quarantine as best you can, and I will have more information for you tomorrow. All right, signing off from the home office here in St. Peter's.